Hi, this is Kaylee, and we're going to build a float accelerometer today. So a float accelerometer is a good way to represent the direction of an acceleration or even a force. So it's a good low-tech way to actually give direction to an acceleration. So to build it, it's pretty easy. You need some string, some plastic that's kind of flat. I got this one off the side of a milk carton. A jar, a plastic jar, and a float, as well as some scissors and a marker. And we're going to build something that looks like this, except a slightly nicer version because this one still has peanut butter in it. But this one's brand new. So the first thing I want to do is I want to make a little gasket to actually hold that string in place. So I'm just going to take this, put it down on that plastic, and I'm going to outline it with my Sharpie. This will give me a rough start on cutting out a gasket that is just a little bit smaller that will fit over this so it doesn't leak or leak very much. So now that I got it marked, I want to cut that out. And I'm going to cut it out so that I'm cutting out on the inside of that Sharpie mark, so it's close to the size of the opening of that jar. I may have to trim it down some, but we'll see how close I am when I get it finished here in just a second. By the way, this is a good way to repurpose some stuff that might usually end up in the trash. You can actually build a demonstration out of it. Let's see how close this is. That's not bad. I want to trim it down just a little bit more in some spots. Just to make sure it fits well. If it's a little bit too big, that's okay. It's always easier to cut things off than to put things back on. So that is about right. Now that I got this cut out, I want to punch a couple of holes in the middle of this. And I'm just going to use a nail to punch 2 holes through this, so I can run my string through it. Okay, 2 holes punched in. And then the string. Again, it's always better to have too much than not enough. So I'm going to get more string than I would actually need for this. And start off by feeding it through these 2 holes. Like so. And what I want to do is I need to get an estimate about how far I want my floater to be, because we don't want to hit the bottom, but we do want as long a string as we can get so it's more visible and it moves more. So I'm going to attach it, instead of this way, I'm actually going to attach it with this pointing towards the plate. That way it floats, or when I put it into float, the red side's up so it's a little bit more visible. So if I can get my string to cooperate. There we go. All right. And let's see about where I want this inside that. Okay, that's too low. So I want it somewhere right about there. So I want to take this, and I'm going to use my Sharpie to mark the string right there so that I know exactly where I want to tie that off at. So, and then just tie the string up to it. Use whatever knot you enjoy the most. I am going to just use a very basic knot, and I tried this with a shorter string and it was much harder. So the longer the string, the better. Then you just cut it to the size that you want. That will be just fine. So I want to tighten that, and then I can cut off the extra string that I don't need. Like so. Now let's make sure this fits in here. Nice. Actually, that's the wrong lid. It's this one. But they still work. So now we have a float accelerometer. So what we need to do is actually dampen the motion because it moves too fast. And the best way to dampen the motion is with water, and then that's also the way it floats. Give me a second to fill this up with water and I'll show you how it works. Okay, I've made two of these, so we're going to put both of them together. Here's this one. And you want to fill it mostly up with water. There's that one. And then, what do I do with the other top? There it is. Okay, now let's do the other one. Okay, so right now they're at the top, you can't see them, but if you turn them over, now you've got a float accelerometer. So the float will point in the direction of the acceleration. So when I move that way, it points that direction. When I slow down, it pointed the other direction. So speeding up, slowing down. Speeding up, slowing down. Now, the neat thing is if you make two of these and you have a Lazy Susan or a turntable, you can actually do centripetal force as well. So let me clear this out of the way and bring in my turntable. Okay, I've got my turntable here. It's a really good one. And I've got this 1x4 that I cut to be about 2 feet long, and I glued in a square dowel on these sides so that I could place my float accelerometers on either side. And the way I put the bracket is so that they won't fall off and it becomes an inertia demonstration. So I can give it a spin. And you see it points towards the center. So you can talk about centripetal force. Alright, well thank you for watching this video about building a float accelerometer. They're really easy to build, and you just use materials that would normally be thrown in the garbage for most of it, besides for the float. And it's a really simple in-class way that you can show the direction of acceleration. Thank you, and tune in again for more physics builds. Goodbye.